Welcome to Cycle 1 of Investigating Science, Module 7 and 8, which will be combined for this 2021 course. So firstly, we're going to start with our do now. I want you to deconstruct this advertisement on the right. Do you know what brand it is? What is the claim that they're trying to make? Can you identify some of the words in the article that might engage the shopper emotionally? Do you have enough data to trust the claim that this advertisement is making? And how could you test this claim scientifically? So pause this video now and give this a go. So hopefully you are able to recognize this is a campaign that was actually banned, but by Lorna Jane at the height of the COVID pandemic. So when we're looking at this cycle, we're looking at a few different inquiry questions, and this cycle actually goes over 4 weeks. So lots of information that we'll be getting through. So just make sure you pause the video whenever you're completing an activity, or if you need to some time to digest the information. So I've broken this cycle into 6 different parts with 6 main ideas, and I guess we're looking at testing a claim, the influence of sample selection and sample size, emotive advertising versus evidence-based claims, impacts on investigations, the influences on collection and interpretation of data, and correlation and causation. And each of those parts have, as you can see there, different tasks that are mapped to the success criteria. And our learning intention for this cycle is to evaluate the factors that affect the collection and interpretation of data used to support or refute scientific claims. So firstly, we're going to start with claims of truth. So the claim represents the answer to an inquiry question. And claims, if they are as the result of scientific investigations, are justified using evidence and reasoning, usually with data that's been measured and collected, observations, and the evidence usually then is an interpretation of the data. And depending on who the person is who is making this interpretation, what their background is, and what evidence, and if they're using all of the evidence, will depend on how they actually interpret that data. So the explanations that come from this form a body of knowledge that's referred to as scientific knowledge. And this knowledge is represented as theories, hypotheses, laws, models, and facts. And we'll look at how the media puts spins on those terms in the next cycle. But currently, I want us to look at the 3 definitions here. What something is true? It's a depiction of a phenomena that conforms to or reflects reality. A contradiction is a statement or depiction that is inconsistent and does not adhere to logic when compared to one or more other statements or depictions. And then we also have counterclaims, a claim made to offset or in opposition to another claim. So we've got these 2 advertisements here that both make their own claims. So the top one is vitamin water, which we all would have known was a craze a fair few years ago now. Okay, but some of the claims that they make, and you may want to look at theirs in more detail. And then we have also our Special K. And so what is really interesting about these advertisements and their claims is that they actually have the little disclaimer. And so we can see that little asterisk right at the end of the sentence in the Special K advertisement. And always the claims they're making, you'll then see the disclaimer, only if consumed as part of a balanced diet. So what we start to think of here is when people are making these claims, so it's the healthy start to the day as part of a balanced breakfast. So are they actually using evidence, or is this just a way of spinning the information through the media? We usually test a claim through an investigation. And if we are conducting an experiment, we want to make sure it's valid. So a term that we've looked at many times before. So any claim or conclusion of an investigation should be the product of a fair test. So make sure only having one independent variable, a really controlled experiment with a clearly defined hypothesis. So as long as this information that's collected is analyzed and actually is quite reliable, okay, and accurate, all of the terms we've used before, this will help us to understand and actually know whether the claim they are making is true or not. So we want to make sure that the data is reliable. So the consistency of the data when the experiment is repeated, and that's really important when, especially when advertisers are trying to make claims. And then the last we're looking at is the accuracy of the procedure. So how close the observed value is to the true value, or how well repeated measurements of a variable within the same experiment agree with each other. And we're also making sure that we're reducing the number of random and systematic errors here. The next idea is sampling. And so depending on the experiment will depend on how many samples and what's the appropriate sample size. And you'll see as part of your lessons, the Australian Bureau of Statistics has a sample size calculator, which should help you if you're trying to plan an investigation. What would make a statistically, accurate sample size? So there's such thing as selection bias. So where individuals in a study are not randomly assigned to groups. So this can obviously, all of these, can in fact have an impact on the results that the experiment is getting. The next is sampling bias. So is where all of different individuals in a diverse population are not equally represented in the samples. For example, the racial profile of a human study does not reflect the population's racial profile. And then we have the other ones that fall under these that are also forms of sampling bias. So we have convenient sampling, and that's because the people would just be there. They might be, at the shops and they're actually purchasing that product. So that would be quite convenient to sample those people. And then the other one we have is a voluntary response sample. So a sample that is investigated because they are willing to take part in the investigation. Sample size, as we mentioned before, is the number of trials or participants in an investigation. And a small sample size is too small to eliminate random chance. And the greater the sample size, the more reliable the results are likely to be. But there are lots of factors which can come into selecting a sample size. If you're paying people for the investigation, too many people, it costs too much money. What kind of software are you using? So all of these kind of things come into play when you're looking at selecting your sample size. But we want to make sure that our confidence level is quite high. So the confidence level is expressed as a percentage, and it's the likelihood that a repeated investigation on a random sample will produce a comparable result. And then we have a confidence interval, where it's a value with an associated margin of error that indicates the range in which a random sample from the population is likely to fall into for a given measurement or treatment. So I guess the idea is that we're now connecting this to our research. So obviously, scientific research experiments are conducted on samples. So for example, we've got people, animals, plants, objects, substances. So samples are smaller portions of a large population. So obviously we can't sample everybody. That would be way too time consuming. But the sample size and the people and animals, objects, substances that are part of our investigation can have a significant impact on the outcome. So they must be chosen so that they reasonably attain relevant answers to the inquiry questions, but don't have any bias associated with them. So we want to make sure that convenience and cost and availability are obviously looked at and researched, but we don't want to make sure that they then influence the results that we get. So the variability in the samples used in the investigation can affect the accuracy and reliability. So in order to reduce this, larger sample size should be used. And obviously, like we mentioned before, small sample sizes increase the variability, resulting in a larger standard deviation. So this means they're less precise and therefore then become statistically insignificant. And then obviously, like we mentioned lots of times before, sample selection is an important aspect of experimental design, making sure that it's representative of target population and randomly selected and people are randomly assigned to the groups if they are part of the investigation. So we can see two examples here where sampling has come into effect. So there was a review of functional magnetic resonance imaging, and it only involves about 30 subjects. So the researchers actually found at the end of this investigation that the number is too small to produce statistically valid conclusions. So it should have, in this case, represented 100 or more different subjects. But it would have cost a lot of money to get these images collected for over 100 patients. And then we also have an investigation that was looking at the health benefits of a Mediterranean diet. However, the researchers placed members of the same family in the same groups when they were looking at different diets. So this could have introduced bias into the sampling process. Therefore, it could artificially inflate the characteristics of those groups. And then it actually needed to retract their data and revise the paper that they actually put out as a result of this sampling error. So you can follow this YouTube link on the Google slides to look at the different types of sampling methods that you may use in an investigation. I'm going to skip this one here. Okay. Then we go to evidence-based claims. So, like we looked at in the first couple of slides, if advertisers and scientists and researchers are going to make claims, they need to make sure that they're evidence-based. However, some products are designed to provoke a motive response in users, in purchasers, and the fact that they are scientifically validated, they're using quite simple words to make people think that they are, in fact, as a result of scientific investigation. So, like things like scientifically tested or clinically tested. These words can be used in advertisements that actually have been undergone a scientific research process. So claims may also be based on evidence that is produced from their tests, but the way in which these terms are used in the media can often give us mixed results. So when we talk about efficacy, it's the ability of a product or process to produce a desired result. So we're looking at what are the claims that advertisers are making, and do they match with the actual outcomes that the product can give you? There are always health claims on advertising. It's one of the parts that we're going to focus on in the next set of activities. And so there are advertisers on food packaging that can fall into one of three categories. They can either be health claims, nutrient content claims, or they can be structure and function claims. So things like calcium for healthy bones and teeth. The way in which these terms are used in advertisements can actually entice the purchaser, the consumer, to actually buy the products based on these claims. So things like as well reduced fat milk or low in salt, and also things like calcium builds strong bones. So where possible, all claims should be tested through first-hand investigations. It can actually come back through the Consumer Commission if advertisers are using these and they haven't gone through the correct process. The next set of impacts on investigations can be the way in which groups and the way trials are conducted. So there are three things we're going to look at that may impact investigations. The first are control groups, the second are placebos, and then we're going to look at double-blind trials. It's also good to pause the video and watch the video that does explain each of those three things as well, but we'll go through what each of those things are. Control groups are the group in investigation that's used as a benchmark or comparison to a group that usually receives a treatment. So this is used to determine whether a particular treatment or process applied to a sample group actually has an effect. And in this case, it's used to determine the efficacy of a treatment. The next are what we call placebos. And these are usually medicines or procedures that have no therapeutic effect. And this allows the comparison of the treatment group with the placebo group to identify any false positives. And then the third one, if we go to the next slide, double-blind trials. So this is a technique where neither the participants or the researcher that's making contact with the participants actually know who's getting the treatment and who's receiving the control. So it's usually used during taste testing. So the person conducting the testing doesn't actually know what the food is, and neither does the actual patient or the consumer who's actually eating the food. So it means that there can be no bias. There can be no one who's swaying someone in one direction or not, because no one actually knows. They're all unaware of the test being conducted and who's actually receiving the treatment or the test pills. So there can be other influences on the collection and interpretation of data, and they can either be societal or economic. So when we talk about societal, they can be things from a cultural background, religious ideas, how significant different issues are, so it relates to people's values, the time or effect of the issue, so whether it's long or short term, if there's any effect on human health, and therefore, I guess, if there's any policy changes that are required. So depending on what people's ideals are and their own personal opinions will influence the collection and interpretation of different parts of data. And then we have the economic influences, which are things like money and financial investment. What's the political climate like? Do the politicians actually want to collect the information? Do they want to spin it in a way that's suitable to them? What impact would that have on global trade or jobs? So there can be a range of different issues which will affect how information, and if information is collected, and therefore then how it is interpreted. So the things like climate variation data. So the way in which that information is collected indicates that people may interpret the data in ways that reinforce their biases. So they're only collecting information that will support their, their opinion. So usually there's motivated reasoning that underlies their interpretation. There's things like political affiliation, and things like economic factors. So if there's different lobby groups that are contributing money or financial benefits to people, so maybe not necessarily analysing all of the data available. And then I guess in terms of remedies for health conditions, so depending on what group is collecting the information, they may have actually vested interest on how these health remedies are generated and interpreted. So things like companies that manufacture the remedies, things like overcoming nicotine addiction. So they have numerous studies into the effectiveness of such therapies. So obviously they're going to put their money into looking at how effective they are. They're actually probably not going to see if they are ineffective. So sometimes these actually have no biases, but other times, depending on who makes those claims and what kind of research they're conducting, will depend on whether we're actually collecting and interpreting all of the possible information or whether there are in fact biases at play here. So again, we have bias in statistics. So we can look at the different techniques that people use might actually sway the information in a certain way. So statistical analysis techniques that are used to analyze a problem can have significant effects on the decisions that scientists make. And there are this video and some questions to follow that as well. So it might seem like poor practice, but there are ways in which people actually manipulate statistical data because these outcomes are really important in decision making and what would happen in the future. So researchers often use statistical tools to analyze the data collected, but errors and the way which the statistical analysis is done will depend on whether there are actually reliable results being achieved. So if it's a biased sample or incorrect group assignments, it may lead to results that are used to substantiate desired outcomes. So what the researcher actually wants to find out, they don't necessarily want to be contradicted or have to change their mind. So such misrepresentations were behind the retraction of the paper describing the Mediterranean diet, which we looked at before. And so if the raw data that is collected is processed before further analysis, this can remove outliers and remove different measurements and fix missing data. So while that's a legitimate practice, it can actually manipulate the data and produce invalid results. This then leads us to the idea of correlation and causation, which we have looked at in year 11. But remembering that correlation is a connection between two or more things, or a measure of how things are related, whereas causation is where a change in one variable affects the other variable, and also referred to as cause and effect. So to establish causality, the following three conditions must be met. The cause must occur before the effect. When the cause changes, the effect should vary. And there are no other plausible alternatives. So all other variables and confounding factors have been kept constant. And we know the typical example. So the correlation between ice cream sales and shark attack. There's no actual causation. Sharks don't attack people who eat ice cream. But if we look at the data and put that on a graph, we can actually see it is a connection between those, but they're not actually causing one another. So depending on whether we're looking at correlation or causation, we can actually spin information in a way that might actually scare the general public. So another video here that you can pause the video and watch. So there are a few examples here which the syllabus points out to us, which are actually a way in which scientists, I guess, have used that correlation and causation to change the way that we look at certain effects here, and we're going to look at these now. So the first one is the Hawthorn Effect, and I guess in summary, there was a company that wanted to increase the productivity of its workers. So they observed their workers under different conditions. Okay, so for example, they changed the lighting, or they changed the heat or coolness of the room, and the results of the study were not quite clear. And all the variables tested resulted in improved productivity. And what they actually concluded was that the workers actually performed better because they were being watched. and that they were thinking about what did the people watching them actually want to see, so those expected behaviours. And it's where we came to know this as the Hawthorn Effect. So where the observer was subsequently looking at these people, and humans just in general were just changing their behaviour to, I guess, didn't want to look bad for their boss or those kind of things. So it's considered to be a possible bias that may affect the interpretation of experimental data. So all other explanations should be explored and discounted before concluding that the Hawthorn effect may be responsible for an observed outcome. So that's why we might use, I guess, in lesson observations for teachers, we might actually use video recordings rather than having someone sit in the class, because that observer effect may actually just make the students participate more. The next is the relationship between hormone replacement therapy and CHD. So what we looked at here was that there was a claim that women undergoing hormone replacement therapy would have a lower incidence of CHD. And therefore, people actually stopped taking the hormone replacement therapy tablets, resulting in more health issues, I guess. So the correlation between these two things was published, and there was numerous studies that followed that contradicted the findings of this paper. And the reasons why this was found to be incorrect is that the authors were selective in the use of the data from the literature, and they ignored anything that contradicted their thesis, and they didn't have any other variables. For example, the socioeconomic status of people strongly correlates with their risk of developing CHD, and the authors did not control those factors. So this was another, I guess, the idea of that correlation and not causation, which resulted in some really misleading information to the public, and probably impacted a lot of human health because people stopped taking those hormone replacement tablets. And then we have the Mozart effect. So a study published in 1993 showed that students who were exposed to Mozart's music for 10 minutes prior to engaging in spatial reasoning tasks actually performed better than those who listened to relaxation sounds or silence. What they didn't publish in that was that the effect only lasted for 15 minutes and actually didn't have any impact on the intelligence of the participants. But what was disseminated in popular media was that Mozart makes you smarter. So just like this lady in the picture at the top starts making her little baby listen to Mozart in hope that it will be smart. But it allowed an industry to be developed where it enhanced child development through listening to classical music. But although the studies showed the benefit of listening to music, there's no evidence that the music actually enhanced intelligence. And while this probably doesn't have an effect on human health, and there's no actual causal relationship between listening to music and, I guess, academic performance, this is one of those things where it was published because there was some correlation, not actually any causation. So now there was a lot of information into one video, but that concludes our cycle 1. Remember to go back and answer your inquiry questions using the information collected from this cycle, making sure that you're also completing the Google form with the past HSC questions to give you some more practice.